much more can I take? How long before I break? You got me feeling, oh, you got me feeling so restless. What move should I make? So much to lose when your heart's at stake. You got me feeling, oh, you got me feeling so restless. I know what to do. Never should have trusted someone like you. You got me feeling, oh, you got me feeling so restless. There's nothing left to say. I don't wanna leave, but I know I can stay. Oh, you got me feeling, oh, you got me feeling so restless.
Hey, how's it going everyone? Hope you're having a good week. I certainly am. It's a bit of a short week for me. I'm off to RoxCon on Friday, flying Brisbane to Melbourne, so very much looking forward to that. Cheers, by the way. Now I know on Sunday I promised we'd be finishing off, or hopefully finishing off, micro corruption tonight. Hey, Change Artist. But last night I decided to do half a job. Decided to do half a job of something, and I want to finish that off tonight. I'd really like to finish what I'm working on. Was walking through my house and it hit me stream time. I'd like to get this done before Rux. So you can see, and what I've done also is because last week, or last session, last stream, there are a lot of people showing up saying, hey, what's going on here? If you lovely folks could please let them know what I'm working on, that'd be great. It stops me having to kind of flick back and forth and lose what I'm working on. But as well as that, in the description down below, there should be a little bit of a blurb about this stream tonight. If you could point people there, that would be much appreciated. So what I'm working on is, to back up a bit, the other night I was working on a little crappy exploit DB vulnerable bit of software that someone put me onto. So it was a Windows binary. And recently I've picked up Pwntools, and I'm loving Pwntools for exploit dev. But I was working on this binary, and as a lot of you know, when you're working on Windows binaries, you use either WinDebug or Immunity Debugger, and then you use Mona, which is a plugin that helps with exploit dev tasks. Mona has this really good feature called Find MSP. Actually, I wonder if we can get some docs up so I can punctuate what I'm saying with references and whatnot. Let's go GitHub. So Mona is a plugin for Immunity and WinDebug, and you get very little in the way of instructions. And it comes with this function called Find MSP. I could have sworn it came with something called Find MSP. Find MSP. Find MSP. Find. Find. The code's making a fool out of me. Okay, here we go. Come on, Chromium, catch up. This will do. Find MSP, what it does is it finds cyclic patterns in memory. So what it'll do is it'll automatically crawl through memory for you and find any instance of the cyclic pattern. It'll find pointers to the cyclic pattern. It'll look at the registers and see which registers contain parts of the cyclic pattern. It'll look at the registers and try and figure out which ones point into a copy of the cyclic pattern. Really nice feature that I rely on heavily. It helps to find all sorts of useful cases in which you didn't know there was a copy of your payload over here, and then this pointer points to it, or there's a pointer on the stack that points to it, or what have you. It can get you out of really tight spots. It's really nice. The issue I had this weekend was that Find MSP is hard-coded to look for the MSP, the Metasploit pattern, which I've got in the description. What's the name of the function that... It's like Rex text pattern create, I think. Yeah, it's somewhere. And Pwntools also implements a cyclic pattern generator, but it's a different brand to the Metasploit one. It generates a cyclic pattern that looks different. So I was rocking out. I was writing my exploit. Let's just install Pwntools, the dev copy. Alright, so I'll just quickly flick across. Really should have planned out how I was going to introduce this. I'm flicking everywhere. Pwntools is great. Pwntools is a bunch of exploit dev helper functiony stuff. It's a Python library that makes interaction with processes, remote hosts, and also general exploitation tasks really easy. I'm loving Pwntools. So to install it, you basically just clone this repo here, and then you do a pip install -e dot, I think. I mean, you can install it from pip as well, straight from pip, but I like to get the code so I can hack on it, as I'll be doing tonight. To install it from a copy of the code, you do a pip install -e dot. Go and whack a -- user onto your pip install, and it just installs it into your home directory, so you're not junking up your system. Alright, this is going to be too slow for me to make a demo of it. I'll let that chug along. So Pwntools implements a, actually you know what, I'll just go to my, oh no, it's almost done. No, screw it. I'll just go to my host and do it there. This is, as usual, this is a Docker container here. So while that chugs along, Pwntools comes with pwn.cyclic 64, and it punches out a 64 character long cyclic pattern. Then you've got Metasploit framework, ships with tools, exploit, pattern create, -L for length, 64. And once Ruby wakes up, you can see that it also punches out a 64 character long cyclic pattern. With Pwntools, you can crank this right up to 1024 and get a much longer pattern. And the cool thing about these patterns is every 4 consecutive characters is unique until the pattern has to repeat itself because you've asked for way too much data. But the size of patterns that I normally pull out of it means I don't get those repetitions. So every 4 characters is unique, and like with Pwntools, you can go pwn.cyclic_find, give it any 4 of these characters, and it tells you how many bytes into a cyclic pattern those 4 characters appear. So it makes it really nice to basically find offsets. Same thing with Metasploit, you can crank this up to 1024. And you can do pattern offset. What's the usage of this? Query for, let's say, these 4 characters here. And you find out that there's a match at 672 bytes into the cyclic pattern. I haven't tried this yet, but what happens if you try to use a Metasploit pattern in Pwntools? -1, couldn't find it. If you go to Metasploit and you query for a Pwntools string, it tells you that, yeah, it couldn't find it. So these are incompatible implementations of cyclic patterns. We done? Yeah, we're done. Don't need you anymore. And so as I said, Mona gives you this really nice feature of find MSP. So I'm sitting here working in Pwntools. I'm having to go to Metasploit and copy paste these huge chunks of characters across to my Python script as part of my exploit to find offsets, just so that I can tell Mona, hey, go hunting for a pattern for me. And that was really annoying me. So I thought, hey, why don't I go and see if I can port the Ruby implementation of Metasploit's pattern to Python. And I did that last night, and I want to redo that on stream because I thought it was a good exercise. And then if we've got time after that, I will work on integrating it into Pwntools, and hopefully we'll get as far as actually sending off a pull request to see if we can actually get it landed in the Pwntools project. Because I think this would be really good for me, even if the project doesn't accept it, even if they go, oh, we're not too interested in having a Metasploit pattern generator in our exploit development framework. I'll go, nah, that's cool. I'll just use it myself because I'm going to find it super handy. And I'm sure others will as well, and if they want to grab my patch and apply it to their copy of Pwntools, that's the wonder of open source, they can totally do that. So, if that makes sense to anyone, if there's any questions, queries, concerns about what's happening, please make sure you yell at me in the chat. If there's any issues with audio, please yell at me in the chat. But apart from that, I'll get cracking. So I re-implemented pattern create in Python last night, but I won't peek at that. I'll see if I can do it from scratch. I'm having some issues with this as well. The performance isn't as good as I would like. So, as well, tonight I hope to get to the bottom of my performance issues. So, let's dive into Metasploit. Metasploit framework. Actually, no. The library's not even in that directory, in that project. And Docker's unhappy because I've got this git prompt that is probably chewing through the whole repo. Let's go and get Metasploit's Rex library. Really? The code that, there's a front-end tool for pattern create in tools exploit exploit pattern create.rb. Give a length of 8. So here's like a little world accessible, public interface to this function. And man, Doc is really sleepy tonight. But if you have a look at this Ruby file, all it really ends up doing is pulling in the Rex text gem and basically calling out to Rex text pattern create. So the code is in another castle. The castle it is in is the Rex text project. So let's grab a copy of this. Just so we can take a peek at their code. Cool. Let's go to opt. Let's go to work, MSF, Rex text, yep. So the logic is in 2 different areas. I know that it's in text/pattern, as well as in Rex text.rb. So here's the first file. This is pattern.rb, and this actually defines the pattern create function. The rub is that this function here refers to this converge sets function, which is in the text.rb file. So these 2 functions are what we need to have a look at to understand how Metasploit has implemented their generator. Let's just go and copy paste their code. Let's go and edit work MSF MSF pattern create .rb. Let's just go and create. Let's just go and copy paste the relevant bits of code into our own file. So we need this converge sets function. There it is. Oops, cut off a bit too much there. And buff end. You know what? I don't trust myself. Let's go and get that again. 22 lines. There we go. It's looking better. So we need the converge sets. Let's just go and get rid of this here and call it converge sets. We also need the pattern create function. Okay, that ran without issues. How do we access argv in Ruby? Okay, so argv0 is the first argument. argv. Yeah, that looks good. Do I need to convert it to an integer? So we want to call pattern create on this. And get rid of this here. Okay, so I need to pull in the constant upper alpha, which is here. I know we need these three constants. Alright, there we go. So we've just gone and copy pasted all the Ruby code across to our own file so we can go and dig into it, add printf statements and whatever we need to. So let's close those buffers we don't need anymore. Okay, so here's our Ruby code. So pattern create takes two arguments, length and sets. Sets, if you don't specify it when you call this function, defaults to nil, and if it is nil, then it gets set here. You know, if sets is not set, then set it to an array containing first element is the upper alpha, second is the lower alpha, and third is the numerals. And then these three constants here are just strings. Strings of all the uppercase letters, strings of all the lowercase letters, and strings of all the numerals. So sets lets you tools, exploit, pattern create. Lets you specify some different sets of characters to use instead of all letters, all the numbers. So I guess you could do stuff like length of 16, sets being ABC, XYZ, 987. And it would basically remix these three sets of characters and look totally stupid in doing so. Maybe need commas here. Yeah, so it uses my A, my X, my 9, my AX8, AX7, AY, blah blah blah. We're not going to bother implementing this when porting it to Python and then putting it in Pwntools. I don't think there's much of a use for it. The Pwntools implementation is already pretty good. You can do stuff like alphabet equals just the numbers, and then we'll go and make a cyclic pattern just out of numbers. So it already has the ability to specify alphabets. I don't think it's that useful to go and add the Metasploit equivalent, the Metasploit pattern equivalent, with the ability to specify these sets, because really I think if you're using this function inside Pwntools, really you're just doing it so you can do Mona's find MSP. You're not going to use this as a general purpose pattern. You do have built-in one to Pwntools for that. I don't think it's important to provide this sets ability, so we're just going to hard code the sets to be upper alpha, lower alpha, and numerals. So what's this Ruby code doing? I tried to unpick it last night. What it's doing is it's starting off with an empty buffer, which ends up being what it returns. So buff is where it will build up the cyclic pattern progressively and then return it at the end here. Offset starts off as empty list. We initialize sets if it's not already defined to be a list of the first element being upper alpha, the second being lower alpha, the third being numerals. We then return stupid uses. If someone's gone and given a stupid number, like 0 or -1, we go and give back empty string, go away. If they've only given one set of characters, like I managed to do right here, so I only gave the ABC, these got ignored, I only gave the ABC set, then it thinks it was a stupid use, and it just returns no, it's doing if set size equals 1 and sets 0.size equal 1. So if we'd done the set being just the letter A, that's when this line kicks in and just kicks out a whole bunch of A's for us. You know, it's going to be A times length. Do we need to... We might need to think about how we handle edge cases in how we're being queried, but we can cover that off at the end. Then what it's doing is it's getting this idea of sets, which if you don't define it will be this here. Then it's getting the length of the sets list, which in this case is going to be 3. Then dot times is just 3 times do this. So what this has the effect of is that offsets, which is empty list already, has, in this case here, 3 elements appended to it, where each element is the number 0. So what this is doing here is basically initializing the offsets list to be the same length as the sets list, but just full of 0. So in our case, it'll be a list of length 3, with them all being the number 0 in this case here. So once we've initialized the offsets list, we then, until buff.length is greater than or equal to length, so until the buffer is big enough to satisfy how long we wanted it to be, then do this. We append, this here means append, we append to buff the return value of converged sets with the parameters sets, which we know is going to be this here, the number 0, offsets, which is going to be a list full of zeros of the same length as the sets list, and length, which was the parameter that got passed in. So we call converged sets with these parameters, and then whatever this returns, we go and append onto buff. And we keep on doing this until buff.length is greater than or equal to length. And that's why this confused me. I think this is dead code, because this is saying if buff.length is less than length, if it's not long enough yet, then do buff equals buff and just kind of double, triple, quadruple the length of buff until it's long enough. So just repeat buff over and over again until it actually is long enough. Then at the very end, we just return buff from the first character, or the 0th element, up to the lengtheth element of the string, because buff is a string, yep. So this here just returns, you know, if for example, this here resulted in a cyclic pattern that's a bit too long, if this here resulted in a cyclic pattern that's just a bit too long, this will basically chop it off to the length that the user asked for and return it. So I'm pretty sure this is dead code. I want to do some tests on this. If it is dead code, I'll probably just submit a pull request to get rid of it, because it's confusing and it's not being hit by the test cases. And it's not needed. So let's have a look at how converged sets works, because really this just gets run enough times to fill buff up to the length that it needs to be. So the real work is being done inside converged sets. So we have a look at converged sets. Then it starts off with these parameters here. I'm just going to copy this line here. I'm going to put it here and comment it out, so we can see what parameters are being passed. It's not really that interesting. The sets parameter is being passed in for the sets value. What's interesting is index starts off as 0. Offsets is offsets, length is length. So all the variables inside the pattern create that relate to these names here get passed in as the equivalent parameter to converged sets. We can see that converged sets either returns buff or returns buff. So we know that this buff we're building up to be basically one top up of this here, because remember this gets done in a loop until the pattern creates idea of buff is long enough to satisfy the condition of, is it long enough? So this happens in an what did I just, no, I'm good. this happens in a loop until this condition is satisfied. So what do we do? We set buff to be so on the first run through, we're doing buff equals sets 0, because see, you know, index starts off as being 0. It's going to be sets 0, offsets 0 dot character. And remember, by the way, that we know that offsets equals a list of 3 zeros. We know that sets, what was sets? This here. So we're doing sets 0, offsets 0 dot character. So really what we're doing here for this first one is, for the first iteration, or really, yeah, what we're doing is, so sets 0 is upper alpha. This here, offsets, the 0th element of offsets is the number 0 dot character. So really what we're doing is buff equals the first character in this string here. Now we could replace it with this here, .chi, like we're just going to replace upper alpha. Oop, let's go and quote this. So really, buff equals capital A. You know, we go and get the 0th element of this string, and it's the capital A. So we start off with buff equals capital A, which is good because let's actually go and do a proper run of this. There we go. First character of our length 16 pattern create is capital A. I should say, by the way, that really. Every time you run pattern create, you get the same thing out. It's not a random string; it's a predefined string. It's the same each time. So okay, we're on track. Oh, stack trace. Let's do a big one. Let's do 2024. Let's go and copy this actually to our Ruby file so that we know the sort of output we get. Come on, wake up. Man, my machine's really unhappy tonight. Vim's using a whole core. Good job. Man, what did I do to it? Yeah, it's dead. What's going on there? Alright. Things are really broken. Let's go and bounce that pane. Oh, that's looking better. Let's try and recover the file. Vim does not like this file at all. Turn line numbers off. Is it a... I'm having issues with line numbers in Vim lately. They're causing weird things to happen. Alright. Delete that swap file and start again. Let's try again. What do we have? We copied this here. We copied that there. What was the last thing we grabbed? Offsets. So now that offsets is that. Let's try this again. Let's go and copy this. And cross our fingers this time. Vim is really unhappy with pasting that in. It is really unhappy about that. How bizarre. Oh, no, it's recovered. It's recovered. If we scroll around, does it choke? If we scroll around, it does choke. That is really odd. I have not seen that happen before. What if we do a shorter string? Let's just do 16 characters. That way it doesn't have to wrap and stuff. Alrighty. So we can see that, yeah, on the first iteration through, that's right, we had done the whole buff equals sets 0 offsets 0 dot character, which is equal to buff equals sets. We know that sets 0 is upper alpha. We know that the 0th element of offsets is 0 dot character, which is the same as this here, 0.chr, which is the same as buff equals capital A. So that's what this first line here does for this call of the converge sets function. Now, if there are more sets after use, I'm not talking about after use here, converge with them. So if sets index +1, we know that index is 0. If there is a set over there at index +1, there will be. It's this element here. This is index. This is index +1. So that does exist. So then we append a buff, converge sets, index +1, offsets, length. So we can see here that we've got recursion going on. This is where I tried to then unfold the recursive structure and then ended up going, nah, blow it, I'm just going to re-implement from scratch. Because after we possibly recurse, and then when this recursion finishes, because it's kind of gone through all 3 sets, then it should bubble back up, having appended to buff at each step, and then else, while index is greater than or equal to 0, and let's go and highlight these brackets. While this here is equal to 0, this here is really setting offsets index equals all this here. You can see that it's setting in the list of offsets at index, which will end up being 0 in the parent, but in the child it'll be something different, and there's recursing down, there's recursing back up, then there's doing this at each level of the recursion. What it's doing is it's setting one of the elements of offsets to become basically plus equals 1, because it's going and getting it back out and then adding 1 mod whichever index is talking about, go to the sets. So if we were setting this offset element here, we go and look at lower alpha. That's what this means here. Get the length of lower alpha and mod this by that. So what it does is it makes sure that the offset wraps around to be no greater than, like this offset will never be more than 25. Yep, 25, because there's 26 characters in here, there's 26 characters in here, there's 10 in here, so this will never be more than 9. So this basically ensures wrapping, and then if that's equal to 0, then we decrement index, and we're recursing up, left, down, and sideways. If we get to the point where index is less than 0, so if we've basically exhausted the entire list of sets, then we return what we've got so far. Then it's the parent's job to append what we got back to buff, and if it's not enough, this loop should happen again and again and again until buff is long enough. Pretty sure this is dead code, but I'll have to look into that. So when I got to the stage where I kind of saw this recursion, I tried to re-implement a lot of this using the exact same structure. I didn't want to add too many functions to Pwntools. I didn't want to go polluting their namespace with too much nonsense. So I basically tried to unroll this recursion, and that did not go well. So what I ended up doing was actually looking at the output you do get and trying to describe it. So what it does is, actually let's re-implement a little bit of this in Python before we go on. Pwntools is written in Python 2.7, so I'm using Python 2, also because I haven't learned Python 3 yet. So let's implement a little bit of this in Python. First of all, these 3 constants. Let's just go and comment them out, because this is, there's better ways of doing this in Python. Turns out the string library, which the Pwnlib util cyclic. Yeah, so Pwnlib util cyclic already pulls in import string. It already pulls in string, I should say. So if we were to go and use this, we wouldn't be introducing any new library dependencies into Pwntools, and specifically the cyclic module. So that's good. We can use string for free. the string library comes with some constants. String ASCII lowercase, string ASCII uppercase, like this here and this here. Look pretty similar to these. Comes with another string.digits, that there. Cool, so we can go and use these. Let's do it. So in Python terms, we do upper alpha equals string.ascii uppercase, lower alpha equals ASCII lowercase, numerals equals string.digits. So this here is Ruby. This here is Python. But this is kind of useless. All we're doing is pulling in something sensible and renaming it something stupid. So we don't even need that. We'll just comment that out for now, just so we can refer back to what each one is. So that's satisfied this here. Let's look at implementing pattern create. So in Python, that's going to be def pattern create. We'll take a length argument. We're not going to implement sets support. We'll just basically hard code this in. So what we need to do inside pattern create is initialize buff and offsets. We don't really need to do that just yet. Let's go and initialize this here. Sets equals all this. So that's Ruby. In Python, that's going to be sets equals the list of that, and that. So same difference. Based on this here, we just go and make sets be the exact same list as it was over in Rubyland. So with that done, let's come back to edge cases later if we need to. What's the next thing that Ruby does? Okay, it initializes offsets to become a list full of elements equal to 0 n times, where n is the number of elements in the sets list. What we can do is, let's just go and pop a Python REPL. Someone blowing up my pager. In Python we know it's going to be a list of elements full of 0. Like if we do the list 0 times 5, then we get this back here. Cool. So in Python what I would do is offsets equals the list 0 times the length of the sets list. Now if we copy paste this into the Python REPL, we've got to import string. Good at here as well. Then we can see that sets is just a list of those three things there. If we then do offsets equals the list 0 times the length of sets, and there you go, we get a list full of 3 elements of 0. So what that's done is it's satisfied this here. It's satisfied this, it's made offsets be a list. It's satisfied this as well. So then what I did was I actually wandered off and had a look at how... I've got to sneeze. How do I mute the microphone? How do I mute the microphone? Do I need to sneeze? No, I'm good. What I decided to do is have a look at how this actually works. So you can see what it does. This here is the first element, or the first character in this string, uppercase A. This one here is the first character in this string, lowercase a, and this here is the first character in this string here, number 0. Then it kind of repeats itself. So here's one phase in which it's kind of picked the first character of each of those 3 strings. Here what it's done is it's picked the first character of this, the first character of this, but it's picked the second character of this. So we've got AA0, AA1, AA2, AA3, AA4, and it keeps on going. It's basically working its way through all this here. We've got 2, 3, 4, 5, 6, 7, 8, 9, 0. So this here is basically first character, nth character, n times. And then we go to A, B1, AB2, AB3, AB4, all the way up to 0. No, all the way up to, sorry, from 0 to 9. Then we go AC0, AC1, AC, blah, blah, blah. So we're working through all these characters. Then we're working through all these characters, then we're working through all these characters. It's kind of like counting. Like, you know how you do 0, 0, oops, let's go 0, 0, 0, 0, 0, 1, 0, 2, all the way through to 0, 0, 8, 0, 0, 9. Then it's like you've run out of all these numbers, so you go up to 0, 1, 0. 0, 1, 1, 0, 1, 2, 0, 1, 3, all the way up to 0, 9, 8, 0, 9, 9. You've run out of these, you run out of these, so you go up to 1, 0, 0. That's really all the Metasploit pattern does. Just counts up using uppercase letters, lowercase letters, and digits as your numerals. If we're going to do pattern create of length, like, is that 100,000? Yeah, 100,000. Then we get up to, you know, YA8, YA9, YB0, YB1, YB2. You can see it kind of can go for quite a while. I don't know if this might repeat, but so what we're doing is we're looking to use all these, then all those, then all those, and this I like the way that Metasploit used this offsets list. Maybe I'll end up not needing it tonight, but I did use that in last night's implementation. So really what we do is we start off with buff is empty, while len buff is less than length, we do buff plus equals capital A, buff plus equals lowercase a, buff plus equals 0. Sorry, the character 0. Obviously we're not going to sit here and type out the whole Metasploit pattern, but that's the gist. What we want to do is we want to get the first element of this, the first element of that, and the first element of that, and append them all to buff. And we do have this offsets to use. I think I'll use offsets again. I can't think under pressure of a way to do without it. So what we really want to do is we want to go buff plus equals, you know, this is the idea here, but for the first iteration we want to do buff plus equals sets 0, which is this here, the 0th letter of it. Buff plus equals sets 1, 0, you know, we want the first character of this, and so on. We want to get the first character of this. That's going to get us our A0. You know, if we go and get, you know, because sets 0 is this element of sets, then if we go and get the 0th character of it, we get capital A. So how can we express that in a way that's going to be loop friendly? What I ended up doing was you know, for I in range 0 to 2, you really could have done that there. You know, it would have kind of gone through and done. Actually, let's go and leave this in as a comment. Actually, I want to be 0, 3. Same thing. You know, this here is the same thing as that. So we've gone and kind of captured one of the ideas in a loop. This 0 is kind of tricky though, because what we really need to be doing is the first time through we want to get the 0th, 0th, 0th. Then we want the 0th, 0th first, 0th, 0th second, 0th, 0th third. And this one goes up, and then only when this hits 9 does it overflow and cause this one to go up. That's where this offsets kind of comes in, you know, because offsets really is that's what offsets looks like. It's the same length as this, just full of zeros. And really, you use this element of offsets to kind of keep track of how far through string digits you're really interested. Use this one here to track how your offset into this set, and use this offset here to carry, you know, to keep track of where you are in the offset for that set. And so really, these are what ticks over at each kind of run through the sets. So this offsets array kind of ends up coming in handy. Oops, let's just go to Python real quick. So what I ended up doing was let's go and get a copy of this. Sets equals that, import string, boom, and offsets equals this here. So we've got sets and offsets. What I ended up doing was zipping these together. You can go zip, sets, offsets, and what you get back is a list of tuples. You know, the 0th tuple is this here, the second or the first tuple, and then the second tuple. So what this is doing is it's really kind of mixing this 0 with that 0. It's kind of matching them up and pairing them off for you. So what you can do is for I, J in zip the sets and the offsets together. You go print I, print J, and then print a separator. And then you get this. You can actually access this set with the offset you're at, this set with the offset you're at, and then this set with the offset you're at. Like, what if offsets was 5, 4, 2? Let's just say. Then if we were to zip this together, print I, print J, print the separator, then it matches up this 5 with this here, and it comes out there. Matches up this 4 with the second thing in the sets, which was this, and matches up the third one. So it kind of matches the pairing elements of two lists up together when you zip. It's kind of like, you know, when you zip a zipper, the teeth interlock. I probably shouldn't talk about how to program because I'm terrible at it. But that's, I think, the idea of zip. So what we can do is, let's get rid of all this. Let's just go straight to zip. So while the length of buff is less than length, we can do for I, J in zip the sets with the offsets. Buff plus equals, you know, we'll append this, what starts off as an empty string, because we're at the ith set. Actually, no, we don't need to do that. We can just go I, because, you know, I is going to be this first set here. We want the jth element because j is the offsets being zipped together. We can just kind of go and append a buff that once we've interleaved it all. So that's without actually updating this offsets list. Let's just see what this comes out as. What we want to do, let's clean up some of the garbage here. We don't need that. Don't need that. Don't need that. Don't need that. We don't need this anymore. We understand what's going on. Let's go import OS. So we just got a function here. What we really want to do is when this script starts up, we want to do print pattern create sys.arg v number 1. So that needs to be an int. So I need to cast that to an int. So if we run cd work, that's there. Sys is not defined. I thought I got OS. List index out of range. What have I done? Did I specify length? Nope. We get back none. Oh, we didn't return buff. Return buff. Let's bubble it up. There we go. Okay, so it's starting to look kind of like what we need. We've got our AA0, but then we need it to become AA1, AA2, AA3. So we're kind of zipping this. We're zipping these together just fine. But we need to start updating this list as the iterations and the loop iterations go on. We check chat. Denial of sneeze, indeed. No, I can't DDoS someone. That's not what I'm up to. What do you mean? So when you say list comprehensions, frig off Randy, this is 8 minutes ago now. Were you trying to help me out, were you? And steer me towards where I was slowly taking my time to get to. Thanks for that, by the way. Yeah, we're using zip to basically work with lists in a Pythonic way. So we kind of just need to start cranking this up a notch each time through. So what we could do is we could just do, for each iteration through this loop here. We're in this loop here. This is outside the loop. For each iteration through this, we could just do offsets 2. Let's just jump straight to the last element of offsets. Equals, let's go plus equals 1. See what happens. It's going to break. Yep. Because what's happening is we're letting this last element of the offsets list go up above the length of this here. And so it's basically busting through the end of the string.digits string. So we need to do offsets 2 equals offsets 2 plus 1 mod the length of sets 2. Because that way it'll kind of make sure that it loops around as soon as the last element of offsets gets too long for this to be able to be offset by, it'll wrap it around. So if we run that, we get AA0, AA1 all the way through to AA9, but then it stays at AA0 and goes up again. So we're starting to look kind of like, so if we go back to pattern create, I mean, we're starting to look like, really. Because our attempt here is starting to look like it a lot, It's got this, AA0, AA1, AA5, AA9, up to here it's fine, but we need to tick over to AB when we get to this next part. So, just updating offsets 2 is obviously not enough. What we kind of need to do is we need to, if we just, actually, you know what I'm going to do? I'm going to go offsets equals 0, 0. Something, it gives us something to look at. What we need to do is, at this part of the loop, we need to increment this here by 1, making sure we mod by the length of this here, so it doesn't get too big. As soon as this ticks over and becomes 0 again, because it kind of got too big for this, we had to modulo it back around. As soon as this ticks back over to 0, we want to increment this. And then as soon as this ticks over to 0, we then want to increment this. So I'm not sure if there's probably a better way of doing this, but what I ended up doing was for I in the range, I really wanted to kind of go 2, 1, 0, which you can do in Python with range 2, -1, -1. There you go, it gives you 2, 1, 0. Or it turns out you can do, I think it's reversed, range 3. Oop. Yeah, it is reversed, but it gives you back an iterator. You can do for I in reversed range 3, print I, and then you get your 2, 1, 0. This looks much more nice, pretty, and Pythonic, especially when you start to not use the number 3 anymore, but you do it for I in reversed range length of offsets. So what you're going to do is you're going to get the length of offsets, which is 3. You're going to get the range from 0 to 2, which is what range 3 gives you. It gives you 0, 1, 2. Then you're going to reverse it so you get 2, 1, 0. So this lets us walk backwards through this list here, starting off with this, then going to that, then going to that. So if I in that do offsets I, which, if we start off at the number 2, it's going to be this element here, equals offsets I plus 1 mod the length of sets I, which looks pretty similar to this here, except we've replaced the 2 with I so that we can walk backwards through the whole thing. So we'll get rid of this here. Oop, that needs to go inside the while loop. And then what we want to do is, because we're walking, but we don't want to, actually, let's run this to see what happens. Oop, what did I do? What have I done? Aha, brackets. Because modulo is a higher priority thing than addition. Put brackets around this bit here, and so we want to modulo that there. There we go. With this here we get AA0, BB1, CC2, DD3, EE4, FF5. So what we're doing is we're incrementing all of them. We only really want to kind of tick the bottom one over until such time as we need to tick over the next one up. So what we can do is, after we've done this addition, we can say if offsets I didn't just become 0, then we just break out of this for loop. And it's like, okay, for loop, you're done. You don't need to keep on going because we didn't just tick over a 0. If we run that, then we get a metasploit pattern. AA0, AA1, AA2, all the way through to AA9, AB0, AB1, AB2, all the way up to AI5. And if we go and run that there, okay, we've got a problem. We've returned too many characters compared to Metasploit. Metasploit cut off at the A. We had the I5 hang around. So what's happened is, because we're actually appending basically 3 characters at a time before the while gets a chance to stop us, and then we're returning buff, we could possibly return too many characters. So we need to return buff up to length. Alright, so if we were to do, too many things going on. Now you can do like A, B, C, D, E, F. You can go, I want to return up to the 3rd character. You can go, I want to return up to the 4th character, or up to the 1st character. So this here is just shorthand for up to the nth character. So we want to make sure we return buff only to the length that it needs to be, and not to get too carried away. So if we run the Metasploit copy again, we get that. If we run our copy, then we get the same thing. We can check that by getting a hash of what we're doing. So we produce this hash, Metasploit produces this hash, and hopefully the hashes match. Yep, hashes match. So we're generating the same output as Metasploit for a 256 character long pattern. But that could just be luck, you know, we may have just gotten really lucky down at the low end of things. So what we should do is we should get the Metasploit one and do actual more impressive to do it this way. Let's do 1 million characters. Let's do like roughly a megabyte with Metasploit and get the hash of it. There it is. Let's get about a megabyte of ours. Same hash. So even if we're generating a megabyte, which looks like this, we still got the same pattern as Metasploit. Just by even just eyeballing, we didn't even need to unfurl that recursive loop and really try to find out how it works. We just got it basically by looking at the pattern and going, how does this repeat itself? Because really you can see what we're doing is, it's just a fluke that it works this way, but once we kind of tick this here, we don't, actually I'll get rid of that in a second. Once this is equal to like 25, 25, 9, it's kind of like a car odometer. When it ticks over to 0, 0, 0, which is how Metasploit actually repeats itself as well. You could see that it was kind of all wrapped up in a until loop. It was starting over again at 0 with offsets, because this function's idea of offsets is always full of 0. It never gets updated. It's only the child recursive stack frames that get updated copies of offsets. You can see how Metasploit repeats itself is by starting over again at 0, 0, 0. And then once it goes all the way through again, it starts off again at 0, 0, 0. It's kind of just a beautiful accident that we didn't even have to think about it. We just naturally tick back over to 0, 0, 0. So there it is. What Metasploit did with 2 functions, recursion and roughly, let's get rid of the comments and crap. Roughly, do I get a line count? Um, 62 lines. We did in 20 lines and only 1 function, no recursion. So I'm pretty happy with that. Unfortunately, I don't know if it's Python's fault or if it's my fault, but this is not as performant as I would like. So for example, when you do a Metasploit pattern create of a megabyte, if you time it, sorry, that's me, not Metasploit, and that's not long enough. Let's go and do 10 million. So to do 10 million characters, we take 6.5 seconds. When Metasploit does, is it 100 million or 10 million? 2, 3, 1, 2, 3, 10 million. When Metasploit does 10 million, Metasploit takes 8 seconds, which is pretty, or 8.6 seconds, which is pretty good, considering that if Metasploit does one character, it basically takes 3.5 seconds just for Ruby to start up, whereas for our script, for Python to start off, just to do one character, is instant. So we get startup for free, whereas Ruby just takes ages just to start up. But it indicates that there's probably either a deficiency in how Python kind of works with things. I know that there's at least one egregious, poor decision that I made that OJ pointed out to me before I had a chance to try and optimize it. There's one thing I've done that's really horrible for performance, but you can still see that we're doing something wrong. What's really crazy though is if you do Python, pull in Pwntools, and then do pwn.cyclic on 10 million characters. If you print it, then you get this here. If you time it, you get about 0.6 seconds, whereas we took 7 seconds to do the same thing. So the Pwntools implementation of its own cyclic pattern, super optimized. The one that we've just punched out is not so optimized. You got to keep in mind, Pwntools had to basically load a whole library in here to do this, whereas we only imported a few libraries. So that's where we'll leave off for now. I'm going to take a quick 5-minute break. If you need to take a break, step away for a minute, now's the time to do it. We'll pick up in about 5 minutes and see if we can optimize this thing a bit, and then see if we can go and jam it inside of Pwntools. I'll catch you in a second. Where's the pause bar? There it is. Alrighty, we're back. I probably should have filled my water bottle while I was gone. Oh, chance for a second break shortly. So yes, Jardeth, I kind of thought here it was. I thought the lol was a bit cheesy and childish, so I dropped it, but due to popular demand of one, the lol is back. Pritch, your friend very much made me doubt myself, so I actually went and checked, and I'll show you what I found in that check. You're saying that Metasploit only generates the largest unique pattern once in the loop, then jumps out and uses that next loop, the dead code one, to copy the pattern rather than generating again. That's given me a good idea of how to optimize my implementation. The best part is how it goes out. Yeah, I thought that was pretty cool as well. That's actually a really cool optimization. I should probably put that in. I should probably make the effort to generate once and then repeat many times if I need to, rather than chewing my way through the loop, letting the odometer tick over and over again. Good idea. Maybe, depending on which way I go with it. Because I think I'm going to go a different direction. But you said that Metasploit only generates the largest pattern once in the loop, then jumps out. I didn't think it did. Because if you look at the code, here it is. You got this loop here. Until buff.length is greater than or equal to length, do this. Which is going to keep on appending to buff, starting from 0, the output of converged sets. And converged sets will bubble all the way up when it gets to this here. If it exhausts everything, and we've reached the maximum threshold for permutations, it will just return buff and bubble up what it could do. And so even though we've got these spurious begin and end bits of code here, and I believe what they mean in Ruby is they're used for catching exceptions and errors and stuff. And normally you'd kind of follow this with basically an exception handler with what to do when you do catch an error, but there is no handler here. So I think the begin and the end are also dead, but I don't know enough about Ruby to be certain about that. But either way, you can see that in converged sets, there is no throwing of exceptions. I mean, that would be one way that it could probably break out of the loop early. By throwing an exception up to that begin end to handle, and begin end could then choose to break out of the loop. But all you've got is a return buff and an implicit return here of buff. You've got no throwing of exceptions or anything else to signal to this begin end to do something. This is a genuine loop that will continue until this is satisfied. I can't see any way that converged sets can signal to this loop here, break, I'm done looping. So to prove it, what I did was I decorated this here. You know, we can puts at the beginning of pattern create, entering pattern create. We can puts at the end, leaving pattern create. Let's go and put some brackets there. Does puts put a new line? Yes, it does. So we're entering, we're leaving, we puts. If we go and change this puts to just a call, then we don't do anything with what the function returns. There it is, we just say we're entering and we're leaving. We can do here, we can do puts, about to hit the dead code. We can puts here inside the dead code and run it. And we get this, we're entering, we're about to hit the dead code, we're leaving pattern create. We didn't enter the dead code, of course, because we're only doing a pattern of 8 characters long. So just to show again, we're just putsing here, we're entering, putsing here, we're leaving, putsing here, we're about to go into the dead code if this condition succeeds, and then here we're just putsing, we're inside the dead code. And what we're doing is we're doing a pattern create, but we're just chucking the results away. We're not bothering to puts it anymore. So really the maximum length for the pattern should be 26 times 26 times 10, right? So we've got 26 uppercase, 26 lowercase, 10 digits. The maximum length of a Metasploit pattern should be 6,700 characters, I think. So if we run the script and ask for a 6760 character long pattern, we don't enter the dead code. 6761, we still don't enter the dead code. 60,000, we still don't enter the dead code. 600, or even let's do 6 million. For a pattern of 6 million in length, we still didn't go inside the dead code. So for me, is that what, like 100 million? 10 million? Still not inside of it. 100 million. I'm pretty sure it's dead code. If anyone sees an error in my reasoning about this loop and the debug by print that I'm doing to basically try and force the program into that if condition and try to get an announcement via puts that it's inside the dead code, I'm not getting it. So if anyone sees an error in my reasoning or my testing, please let me know. But until proven otherwise, I'm going to say that this is dead code. Even though I'm not fantastic with Ruby, I just can't see how it's ever going to get executed. This is a bad idea. This is taking a while. And dead. I'm not going to bother. Yeah, I'm pretty sure you can't even get inside here. I can't think of a length parameter that would cause this to not come up with a buff long enough that we just don't bother. That we do bother. So that's my reasoning. I'm gonna go and comment that out. Get rid of that. There you go. Yeah. With pattern that long, we didn't. If we scroll up, W, X, Y, Z, A. So you can see we definitely looped. We definitely, with a 10 million or 100 million or 10,000, whatever I just did, we did loop once, and I still didn't get an announcement that we'd gone inside the dead code. So that's my theory anyway. Let's see if we can optimize what we've got. Let's go and get rid of these. Let's get rid of these putses. There we go. Let's collect some performance notes. Actually, that's good. You know, when we're not pulling in all of Metasploit, that's actually that copy of Ruby is super quick to spin up. So what are we going to do? Like 1 million. Time that to dev null. Oh, didn't want Ruby, wanted Python. Let's whack another 0 on there. Okay. So we've got this benchmark here of the Python script doing however many zeros this is, 1, 2, 3, 10 million, takes 6.2 seconds. Let's go time the Ruby one. Ruby takes 4 seconds. So we're not too far behind Ruby. But what makes me sad is let's go and print this just so it's not optimizing it out. Pwn.cyclic is super quick. We should aspire to be at least somewhere close to it. So what it comes down to, we're not too far behind Metasploit, but we're a long way. We're about 10 times slower than Pwntools cyclic. I don't think we're getting it this quick, but we can see if we can get a bit close to it. The other thing is, let's go Vim Pwntools, Pwntools cyclic. The other thing we get is with Pwntools we get cyclic, and we get cyclic find. So I'm not too fussed as to whether we implement cyclic find for the Metasploit flavor over in Pwntools. I mean, I think the most important use for it is to be able to let Mona go and find it. I don't really think anyone's going to bother generating a Metasploit pattern and then using the Metasploit cyclic find within Pwntools to find offsets. Like, if you're going to be doing that, just go and use the cyclic one. It's kind of the one that's baked into Pwntools. It's the one you should use. On the other hand, for completeness, we should probably put it in if we can, just to make sure that the new pattern generator actually has a accompanying function for finding offsets, just to make it complete. We should probably put it in. So we have a look at cyclic find. Actually, let's look at cyclic, and we can see that cyclic is a simple wrapper over func de Bruyne, which returns at most length elements. So it's a wrapper over func de Bruyne. If we look at func de Bruyne, we can see that this here is the actual function that produces the pattern. It's talking about the alphabet, blah, blah, blah. Whereas cyclic really just calls out to de Bruyne. So if we want to try and fit the paradigm that Pwntools is already using, because if we come to the bottom of this file, we've already got a gen find. It returns the first position of subsequence in the generator, or -1 if there is no such position. So we've already got some code in here to basically search a generator's output for a subsequence. And it's like, well, if we're going to put in a pattern, offset finder, it'd be nice if we could reuse this function here, but it seems to take a generator as input. And if we want to kind of fit the flavor of Pwntools, we really should probably have a generator implemented. Just like they've got one for de Bruyne, we should probably have one for Metasploit pattern. That made me go and look at what a Python generator was, because I hadn't used generators before. Python generator. Oh my god, for juice. Right, got some in there. Python generators, Python generators. So it's talking about basically returning lists of things. And here's what a naive example is. Like, if we wanted to add up the first n numbers, we could run sum over this first n function, which returns the first, what's that, million? 1, 2, 3, 1, 2, 3. Yep, first million. So the first million numbers is basically, we start off with num equals 0, nums is an empty list, while number is less than the argument, append to the list the number, and then increment number. And then once this while loop's done, we return nums. This looks kind of like the pattern of what we do. We start with an empty buff, we append to it, we append to it, we append to it, we append to it. That's the other thing. Appending to a list in Python is super slow on the grand scheme of things. Like, when you're doing it once, fine. When you're doing it 10,000, 100,000, or a million times, it gets super expensive, because basically what Python's doing is it's copying the list each time and then appending something to the end. I think it's basically copying the entire list to grow it in size, which obviously adds up. At least I think that's how Python works. And that's what this is here is doing, is getting an empty list and then appending to it, you know, a million times. And it builds the full list in memory. So first of all, it builds the full list in memory. Second of all, I've got a feeling every time it appends, it actually is expensive and needs to grow the list by copying it. And they're kind of going off this theory that what if each number is 10 megabytes big? We don't want to keep a whole list in memory. We just kind of want to be able to stream it to the consumer, and the consumer in this case is sum. And we hope that sum is able to just kind of take in one element at a time instead of waiting to get a whole huge list back out of this here. What have I missed? Yeah, Ruby is weird. Yeah, I'm pretty sure it's dead pritch. Not generating again is surely quicker. Unless we use generators. Unless we should probably do our both things. I'd still like to use a generator because that way we can use that gen find function rather than re-implement a searcher. Generators seem like a cleaner way we can kind of stream to a consumer element at a time rather than giving it back a huge list. Will De Bruyne produce the correct sequence given the same set from MSP? No, but we're not looking to use the De Bruyne function. What I really want to reuse is I want to kind of make my stuff feel like this. They use a generator. We should probably use a generator and fit their pattern. Cyclic really just kind of wraps up De Bruyne, and we can probably reuse this function here. And if we just swap out De Bruyne for Metasploit, we should be gold. Because this here looks pretty agnostic to what we need. It looks like it's just basically consuming from a generator and appending to a list. We'll have a look at what they're doing. Their implementation for cyclic find really just n equals n all then subseq. This is just some kind of setup, some checking for edge cases, but really the guts of their cyclic find is just returning gen find subsequence De Bruyne alphabet n. And then gen find looks like a very generic generator seeker or generator finder, which is agnostic of the actual generator in use. So in this case, the cyclic find function calls gen find with an argument of De Bruyne. We should be able to just do the same sort of thing, but actually put in Metasploit here, and it should still work again. As long as we come up with a Metasploit generator, we should be able to use the same style of function that they use. More importantly, use the same generic guts of their cyclic find function, which is this gen find, which based on a generator will find a subsequence. We should be able to basically reuse this code here. So even though our generator obviously won't be De Bruyne, we've got to make it kind of smell like De Bruyne from the outside so that the functions can live nicely together. Hopefully that was the question you were asking, and hopefully that answer makes sense. So let's play with generators. So this code here is naive. It just basically builds a list element by element. So I've already read this article. This here is a very wordy, explicit example of a generator implemented using a class. So that's an implementation of a generator, or so I'm told, but it's just as an example. Python provides generator functions as a convenient shortcut to actually building this. Let us rewrite the above as a generator function. So here it is. And my chair's going down. The gas lift in this chair is totally stuffed. So here's some example code. We can define a function, first n, which starts off with num equals 0. And while num is less than n, we yield a number and then increment num. So what we're doing here by yielding a number is we're basically bubbling it up to the consumer. The consumer in this case is the sum function. And it means that we will basically, once we yield that number, if sum is not satisfied, and if we haven't met this condition of this loop yet, then we will actually get control back as the child function, and we will increment num by 1 and yield it. And then sum always has the opportunity to go, whoa, I'm done, I don't need you to generate anything else for me, I've actually got everything I need, go away. Or otherwise first n has to keep going until this becomes satisfied, and then sum is like, okay, that's all I'm getting out of it. So this yield looks like a fancy word for return, which basically means bubble it up now, but keep in mind I might need to keep on doing stuff if the parent and if my consumer is not yet satisfied. Then I need to basically remember the state of num so that I can keep on going until my consumer indicates that I'm no longer needed, in which case I will forget num and I will disappear. I'm assuming that's how a generator works. It will generate or yield elements or values until such time as either it decides to shut up or its parent tells it to shut up. So this looks kind of nice. Like if we just go and, as an example, let's just go and pinch this code, toggle line numbers, awesome. Let's go and play with this. Oh. Let's go and sum the first 5 numbers. Cool. Some of the first 5 numbers is 10. Some of the first 50 numbers is 1225. I don't know. I'll believe it. I'm not going to check its math. So this is kind of nice. I mean, sum, I think, is a consumer that can basically have stuff streamed to it. But this looks like a really nice way of representing something that either the parent can tell it to shut up or you can decide to shut up, and you can kind of stream stuff back to your parent without continuously building a list yourself, which kind of seems to be a nice way of doing it. So if we go and got vims all over the place. Didn't have it open, cool. What we can probably do is, rather than, you know, like pattern create, like we can probably call this the generator of pattern. We're going to call it MSF. Let's call it Metasploit Framework Pattern Create. Let's call it generator of MSF Pattern Create. We don't need to keep track of buff anymore, because that's going to be the parent's job. We don't need to append something to buff anymore. We just need to yield it, right? You know, for each of the iterations through here, we just go and yield something. We, as the generator, don't need to keep track of this condition anymore. Does De Bruyne keep track of that condition? De Bruyne alphabet and n. Okay. Oh no, it's substrings of length n. It's not strings of length n. But the return generator will yield up to length of alphabet to the power of n elements. Yeah, De Bruyne doesn't even take a length. You know, cyclic takes a length and an n value, and then it just calls De Bruyne with alphabet and n. We're not implementing the whole n idea in Metasploit because Metasploit doesn't have an idea of this n value. So we don't even need to keep track of length. It's gone. We don't need to keep track of this anymore. Really, it's just while true. Infinite loop. We don't need to return buff length anymore. I think when you really boil down what we did before, that's how you'd express it as a generator. I mean, someone let me know if I've got the wrong idea of generators, but I think that's what you do. And then what you can do is you can print generator MSF pattern create. Get rid of that. And it prints out a generator. So it's actually creating a generator. I then had a look. I should probably just do length equals sys.rv1 integer. So that's there you go. We can capture that 10 as a variable called length now. Actually, you know what? Let's just go and steal. Don't need that anymore. Don't need first n. Don't need that anymore. Let's go and steal Pwntools, util, pwn, util, pwnlib, util, cyclic. Actually, you know, let's just go and steal this here. Let's call this cyclic Metasploit. Let's call this generate MSF pattern. And we'll get rid of that for now. So this from Pwntools, let's go and get rid of the doc string. We don't need the documentation. We're not going to support this whole idea of an n. Oop. So I don't need that anymore. We do need out. For index C in enumerate, we don't need De Bruyne anymore. We're now doing gen MSF pattern, which takes no arguments. If length is not none and index is greater than or equal to length, then break, else out.append C. That's fine. We don't have the idea of alphabets anymore, by the way. Get rid of that. If is instance, we don't have the idea of alphabet anymore. So we just want to return empty string.join. We can see that Pwntools uses 4 spaces, not 2 for indentation, so I'll go and fix mine up now. That's right. So cyclic Metasploit, we start off with empty list called out, and then for index C in enumerate. Does enumerate come for free with Python? Yep. Yep. If length is not none and index is greater than or equal to length, then break, else out.append C, then return empty string.join out. So now we want to print cyclic Metasploit. Where'd my length go? Oh, there it is. Create, no, we want to cyclic Metasploit of length. Print cyclic Metasploit of length. Looks like it works. If we do the Metasploit one of length 100,000 and get a SHA-256, we do ours and we get a SHA-256. Ooh, no, wrong length. Yeah, those hashes match. Let's go and add a 0 to the Ruby. Let's add a 0 to ours. Yep, hashes match. Cool. Let's see if we've actually picked up any performance with this. So then we go to a generator, stole Pwntools cyclic, stole pwn.cyclic, approach to consuming a generator. And what sort of numbers do we get? Let's rerun this test. Please don't tell me it's slower. I'll be pissed if it's slower. It's slower. Awesome. Well, that actually kind of surprised me. By going to a generator, we ended up slower than we were. Alrighty. So at this stage I'm curious, are there any profiling tools for Python? So we can see what we're spending more of our time doing and see if there's anywhere we need to optimize in particular. That looks cool. That looks even cooler. Let's see what this gives us. Huh, that's super neat. I like that a lot. So if we generate a pattern of length 256, looks like we really got to crank this up. 10,000. 100,000. Okay, doesn't go to std, sorry. 10 million. We're destroying the video. Okay. Can we see from this what's causing so much? It took 27 seconds, but if you add up this total time, you don't get 27. Okay, so this range is taking 0.8 seconds all up. This is one place in which I did optimize it last night. You can see here that we do this range, len, offsets, reversed a whole bunch. Does it even tell us method reversed? No. No. But why are we, I mean, this here is generating the exact same thing every time. It's generating the list 3, 2, 1. Like, either we could hard code 3, 2, 1, which I don't really want to do. Like, I didn't even want to hard code 0, 0, 0. I wanted to kind of keep it based on previous values so that we're not hard coding magic values in, because magic values are evil and they make things break when people try to change your code. Why are we doing this over and over again? Why don't we cache this? Why don't we pre-compute it and just reuse that list each time? So offsets, indexes, reversed equals reversed range of len offsets, and instead of this here we can just do this, and it'll just refer to that pre-calculated list, not 3, 2, 1, 2, 1, 0 each time it's needed. So that should buy us a bit of performance. Let's just go back to that benchmark. Okay, that took off quite a bit of time. Pre-calculated this. That saved us some time. Yeah, we shaved off about 3.5 seconds by doing that. That's a win. And we are now quicker than we were before. If we went back to not using a generator, we'd probably be even quicker again. But I want to use a generator. I think it's the right thing to do. This is still pretty expensive. I mean, you wouldn't be generating this that often, but each time you run your exploit, it needs to basically regenerate the pattern because for some reason you decided to use the pattern. Really, you'd only use the pattern in the early stages of dev, but still, I don't want people waiting 5 seconds for a big pattern. Not that you do a bit this big, but it's still kind of gross when you consider that cyclic takes 0.6 seconds. What does the profiler say now? Let's do a profiler for 16. Yeah. Now let's do a profiler for 10 million or 100 million, whatever it is. Let's grep and exclude anything with this in it, so that way we at least don't print the bloody pattern each time we profile. Let's see if this tells us anything interesting. Wasn't that taking like 26 seconds before? Yeah, maybe all this printing was what really blew this number out, because I saw that and just about died, but maybe it was the printing that actually blew that out by as much as it did. 8 seconds is looking better. So what's so expensive this time? Appending to a list looks cheaper. It looks like it is all still in the generator. Zip looks expensive, but it is something we need to do each time through. Unless there's a better way than having that list of offsets and then zipping them together. Unless there's a better way of actually counting what we're up to. How does can we learn anything from De Bruyne? How does De Bruyne work? Okay, so De Bruyne actually does have a function defined within it. And it recurses. Maybe recursion is the way to go. Maybe we do need to recurse to actually hit the performance we need. Because now that I see that Pwntools actually defined a function within a function, I don't feel so guilty doing that. Maybe that's why Metasploit does recursion. I didn't think you could recurse in Python. I thought that was a pretty severe stack limit. I thought recursion was bad in Python. Does Pwntools set the recursion limit? Nope. Hesitant to recurse. I mean, how aggressively does De Bruyne recurse? Can we profile it? And find out how many times DB gets hit. Nope. That's pretty noisy. Okay, this is telling us, I think, how many times DB in the cyclic function got executed. What's with the two numbers? Number of calls. Why is there two numbers? Weird. So for 1,000,000, like that's a pretty. Does it go that many deep? I thought Python stopped you recursing that deep. How's it going? Good to have you around, Kochik. Not sure how to pronounce your name, Kochik, but I'm going to call you Kochik. Good to have you popping in. Yeah, we're trying to port Metasploit's pattern create tool to Pwntools indeed. At the moment I'm trying to figure out if it's a good idea to use recursion, considering Python normally doesn't like recursion. I mean, like, I guess maybe if there's a yield inside the recursion, then it actually... No, it's still going to go deep, isn't it? I might tackle the optimization another night. That seems like a bit of a rabbit hole. For now, let's just jump straight to basically integrating what we've got so far into Pwntools. I will not be submitting it to Pwntools tonight. I need to work on the optimization quite a bit. But let's at least go through the process as to how we would go and fit what we've written into Pwntools. So here's our code. Let's jump into Pwntools. Git branch, what do I call it? Feature, yep. Let's just call this add cyclic metas. Yeah, let's call it that. So let's so we've just branched the code from the current head of dev. I did update this repo today, so we've gone and taken Pwntools dev branch, which is where the new features must land, and we've gone basically forked it into our own branch called feature/add cyclic metasploit. So we can make our own changes in here, and then the idea would be we would commit our changes and then do a pull request from our copy of this branch across to Pwntools' dev branch. Let's quit this. Let's write benchmarks. Let's quit. Okay, good. Let's start Vim again. So we want to Vim our Python file, as well as pwntools/pwnlib/util/cyclic. So this is the file we want to actually end up editing. So that we can see that, nope, that's our file, this is their file. You can see that they're pulling in string for us, so we can use string as part of our functions. So they've got this def de Bruyne, they've got def cyclic find, and then they've got def gen find. So let's go and put our code before gen find, which is the utility function. So we want to create, what do we want to call it? We want to create, I want to say cyclic metasploit. We want to create cyclic metasploit find. And we want to create a generator as well, so we want to define, they called theirs just de Bruyne. So let's call ours, I don't want to create a function called metasploit. It's going to be internal, so we can probably just call it _gen _metasploit for now. I'm going to have to think about what I want to call the generator. We're going to return 1. So let's go and start pulling our code across. So here's our Metasploit generator. I want to go and drop our code there, get rid of this. Do we need to take any arguments? No arguments. And then cyclic Metasploit just takes an argument of length equals none. We're going to copy our code across. Which really, this here, we just stole a lot of Pwntools' code from the way that they do cyclic find. Yeah, I've got a feeling this none is going to end up biting us. So if we just enumerate gen MSF pattern, it'll keep on going forever. Our MSF pattern does not terminate when it gets to 26, 26, 9. I should probably look at having it terminate like that. Because the way that Pwntools cyclic works, if you go and give it a length, it returns something of that length. If you go and give it no length, it'll exhaust the entire sequence down to ZZZZ. I should probably actually have a way for, oops, we need to change this here. What do we call our generator? Underscore gen underscore metasploit. Should probably call that gen metasploit pattern. Yeah, let's call it gen metasploit pattern. I should probably have a way for this to actually terminate. How does De Bruyne terminate? Does it just return? Yeah, so if you return something, it'll terminate. I need to work on putting that in. So let's say that length can be 0 for now. If you just do metasploit pattern, we'll return empty string. For ndxc and enumerate, if length is not equal to 0, no, let's just do if length, if index is equal to length break. Yeah, I might tidy this up before I actually submit it, but that should work for now. Def cyclic metasploit find. How did they do pattern find or cyclic find? Let's go and steal their code. Get rid of this. We didn't have the idea of, I think the argument to cyclic find, you give it subsequence. We don't have the idea of alphabets, we don't have the idea of n, so we just need to make sure there's an argument of subsequence. We don't, width is all if. I'm going to need to revisit this because there is a way that you can provide a integer or a string. So I'm just going to make sure we can only take strings for now. But I'll work on that. Because basically subsequence, if you packing.packet, you get back a string. So let's just continue on the assumption of strings. If n is none, and blah blah blah, log warn subsequence equals subsequence. We don't need that. If any C, where did C come from? Oh, it's for C in subsequence. If any C is not in the alphabet, we don't have the idea of alphabets, so we get rid of that. I'm going to have a problem here with metasploit pattern not terminating, so we can't look for something that doesn't exist. I'll need to do what if subseq can't be found. Our generate does not terminate. N equals n, or we don't need that. We don't need that. So really we've just gone and cut this right down to return gen find subsequence across. What's our generator called? Gen metasploit pattern. Which takes no arguments. Cool, so we're basically just directly wrapping gen find. returns the first position of subsequence in the generator, or -1 if there is no such. Yeah, we need to make sure we can hit this and we don't keep looping. So basically we need to make sure gen metasploit pattern terminates. That looks good. Let's add some doc strings to document what we just added. So the way that documentation in Python works is you just go and put a string right after the function definition, and that becomes basically documentation. That is literally how where's Pwntools? It's gone. Pwntools documentation. It's literally how this here. If you go cyclic, if you look at docs.pwntools.com, search for cyclic, you get pwnlib.util.cyclic. This documentation here literally comes from the code. So the code actually has the documentation baked in, and you run this certain tool over it and you generate a static HTML version of the help, and by basically pulling out all that text that's in the code. And what's even cooler is, this examples here, it wraps up these examples here. As far as I can tell, these are actually your test cases and your unit tests. And there is a Python command that you can run that will scour all of your module for doc strings. It will pull out this example section and it will actually run each of the things you said that the function can do, and it will make sure that you get back what you promised you would. So by putting stuff here, this is actually how you write your test cases, which I think is super rad. I only just found that out last night. So let's go and, did I pinch this yet? I think I did. Let's go and steal this doc string for cyclic and go and put it at the top of our cyclic metasploit. So cyclic metasploit length equals 0. That's all it takes, and it returns a string. It never returns a list. The Pwntools one can return lists in some cases. A simple wrapper over function gen metasploit pattern. This function returns at most. This typo here I actually submitted a patch for last night, so hopefully this doco, next time they generate it, will actually have this typo gone. This function returns at most length elements. Oops. So we go. So we'll wrap our function gen metasploit pattern. This function returns at most length elements. If the given alphabet is a string is returned, otherwise a list is returned. We don't support alphabets. Gone. This function implements metasploits. What's it actually called? Rex text pattern create. There we go, there's our doco, arguments length, the desired length of the string, or none if the entire is desired. To do fix. Because I'm thinking I would like to be able to do this, but I need to make sure the generator terminates. As soon as the generator terminates, I can support this none behavior. So to do fix generator, so this is true. Alphabet, I don't accept alphabets. N, I don't accept N. Example. Let's do this shortly. And then here's our code. Cyclic metasploit find. Let's go and pinch the doco. Cyclic find. Cyclic metasploit find. I take a subsequence, I don't take any other parameters, and it returns an integer. Calculates the position of a substring into a metasploit pattern sequence. To do calculates blah 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 blah. Those to-dos came from the above. Does the doco talk about? Dot dot to do is probably just an internal note. The doco probably doesn't include it. Cyclic find, yeah. So to do, let's leave that to do there. That way our function is to do as well. Argument subseq, the subsequence to look for. This can be either a string, a list, or an integer. To do fix. Can I just fix it? No, it's talking about n to do fix functions, so this can be true. Alphabet, don't support it. N, don't support it. Examples, let's come back into that in a second. Gen find is not our code, we just need to document the generator. Let's go and steal De Bruyne. Yank 10 down. Gen metasploit pattern takes no arguments and returns a generator. Generator for a sequence. Generator for a sequence of unique substrings. This is implemented using a logic behind metasploits. Where's my Rex? There it is. The return generator will yield up to do fix the code so it terminates, and this is true. Arguments, alphabet, I don't take any arguments at all. Do I need to supply arguments if I don't take any? Probably not. Just go and delete that. Do I need to give an example of a generator? Nah. Did they? No, they didn't. Cool, I think that code is done. Let's install it and see what happens. cd Pwntools pip install -e dot -- user. Pwntools installed, so that's just gone and reinstalled Pwntools with our changes. Let's exit that, go back into it. Import pwn.cyclic metasploit 8. There it is. Cyclic metasploit in Pwntools. That looks broken. That looks really broken. Ha! What's gone wrong? AA0, AA1, AB1. BB1, 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 BB1. When did that break? Did our... Yeah, that broke way back then. Dang it! How did I not test that? Let's go back to our code here and see what's wrong. I'm going to grab some water. I'll be back in like 2 minutes. Let's see if we can debug this, and then I can go to bed. Back in a sec. Hey everyone, I've got my bottle of water. I'm keen to get into this and see if we can get to the bottom of the issue I've gone and introduced. I've got some ideas as to where it could be, but I haven't looked at the code. I didn't want to cheat off stream, so we'll see how we go. I'm just catching up on Pwntools' issue as to their Python grievances. Got a script that goes to a page. I'm just going to type rather than talk because otherwise there's a 15-second delay. It's probably quicker to talk than it is to type. We'll see how we go. Hey Legendary, not quite hacking tonight, more so programming, trying to port the Metasploit pattern generator to Pwntools. Show what I mean by like Reddit. If you go to the first page of Reddit, that's all fine. If you go to the next page, things go weird. You get this after equals some ID, so it's really hard to paginate. The URL's like fresh ID equals that, and C equals 10. If I go like, I don't know, bargain.com, or is it .au? It's .au. If we go page 2 on this, what does this URL look like? Page 2. Yeah, there you go. When you go to page 2, it comes up page equals 1, so then you go and just change page equals 1 to page equals 2, and you get to the next page. Page equals 2, change to page equals... Change it to 3, you get to the next page. Like that, to me, would be the easiest way of just fiddling the URL to get to the next page. Might load 20 posts out of 10. Default. So C is the count of posts. That makes a lot of sense. What's this here? What's 2C? C is comma. Maybe it's not base 64, is it? Nope. There you go, Jardeth. Let me copy the link. There you go. Let's go back up here. ID equals blah and C equals 10. Yeah, so you're right, Pwntools. It doesn't look like you're going to be able to just spike the URL to go through the pages. I reckon you're on the right track. I reckon you are going to need to parse the HTML using Python. And what library? lxml.html. Is that a Python library? Yeah. I reckon you're definitely on the right track using a HTML parser. I mean, I don't know if everyone's seen this, but HTML parse regex. Never ever parse HTML with regex. Otherwise, HTML can't be parsed by regex. Regex is not a tool that can be used to correctly parse HTML. Blah 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 blah. If you parse HTML with regex, you are giving in to them and their blasphemous ways, which doom us all to the inhuman toil for the one whose name cannot be expressed in the basic multilingual plane. He comes. HTML plus regex will liquefy the nerves of the sentient, whilst you observe your psyche withering in the onslaught of horror. Regex infection will devour your HTML parser application and existence for all time like Visual Basic, only worse. He comes, do not fight. He comes, his unholy radiance destroying all enlightenment. HTML tags leaking from your eyes like liquid pain. The song of regular expression parsing will extinguish the voices of mortal man from the sphere. I can see it. Can you see it? It is beautiful. The final snuffing of the lies of man, all is lost. Have you tried using an XML parser instead? Brilliant piece of art, this one. If people haven't seen it, I'm just going to drop that in chat. Worth reading. So you're using lxml.html and just the xparse function to get what I want from all the tags I need. I reckon you're going to need to use your XML parser to carve out the link for the next page. That would be the way I'd approach that, with a URL that doesn't have a simple page parameter. If you're wanting to scrape this web page or scrape this website, I think you're going to have to basically parse the HTML, dig out the link to the next page, dig out the href parameter if it's just like an A tag hyperlink, and basically, let's even go to like to Ozbarg, and if we inspect element on one of these pages, then you get a href equals / question page equals 4. I think you're going to need to basically go through and look for example, in this case, for Ozbargen, if you want to go to, we're currently on page equals 4. If you want to go to page equal, this next button here actually would be the way to go. If we inspect the next button, then we get a href equals whoops, lost it. I reckon if you look for the class of PagerNext, then there's probably only one element on this page that has the class PagerNext, and then the href for that is going to be the link to the next page. I reckon you're going to need to, am I sort of hacking now? I'm not even sort of hacking now. I'm really just looking at cheap stuff on Ozbargen. Yeah, I was going to say, if you've got like a JavaScript thing going on, things are going to go weird. Gotcha. I'm not a 9gag user, so I didn't recognize the URL format. Load more posts equals that. What if we just head to 9gag? If we turn on, because the other thing is there may be like a I don't know if 9gag has an API. Like the other thing might be for something like 9gag, just use some sort of API. get section ID, get comments. Right, okay, yeah. Okay, here we go, yeah, InfiniGag. Okay, cool. I mean, even if the website doesn't work, is there actually code or is it just a README? It's just a README. Useless. Right, yeah, okay. I'm not too sure. I'd have to dig into it. I'd have to, yeah, I'd have to have a bit better look at how 9gag actually works and dig into maybe their JavaScript, dig into maybe the network. Like if you go and monitor the traffic using Burp while you go to the next page, if you look at this traffic here, there might be something you can use. But yeah, no, sorry, I can't help you anymore with that. I'm not aware of how 9gag's website works, so you're on your own on that one. I'm sorry. I want to see how you hack. Can you do this? You may say no. I'm going to leave that in your very capable hands to deal with your code. Yeah, good call, Jardev. Legendary. I've got tonight's a bit of a dry night. I'm really just at the moment I'm just chatting because I'm delaying looking at my broken code. Tonight I'm really just doing Python programming. If you go back to my previous stuff, I've got some stuff still on Twitch. Well, the other thing is check out the channel info. I've got a YouTube link, which is where I've sent some other old stuff across to YouTube to avoid Twitch purging it from the archives. I've got some pretty cool stuff there. The micro-corruption series is pretty cool. And if you check out Menstrual's CTF, there should be about 3 or 4 videos I've got on YouTube. It's me basically doing website capture the flag style challenges. They're kind of like little hacking puzzles where you get given a website and you have to break in and steal the data and steal the flag and steal the information. It's all done, and everything I do is authorized. I don't perform unauthorized access to websites or systems. I don't hack into stuff without permission. Everything I do it with permission. So all the stuff I'm streaming are either challenges, stuff with permission, or just looking at old software bugs. So you won't find me doing anything super sexy, super cool, super crazy, black hat kind of stuff. It's all ethical, above board, white hat kind of stuff. But yeah, check out the YouTube channel. There might be some stuff there that tickles your fancy. Alright, I'm going to jump back into my code. Let's see if we can find out how I broke what I broke. Because yeah, even this code here is broken. So if we fix this and then port it across to Pwntools, it should work again. What did I do wrong? Why is it going AA0, AA1? See, that's fine. That's fine. That's broken. Where did I go wrong in life? Was it when I went to a generator, or was it when I optimized this loop upwards? Because I thought I checked the generator with SHA-256, and the generator was fine. Was it this that I stuffed up when I lifted that out? Or is there something wrong with... Actually, you know what I'm going to do? I'm going to use a different function. I'm going to skip the cyclic code that I stole. There is another way of pinching a slice of a generator, but it requires an external library that Pwntools doesn't bring in, and I didn't want to bring it in if they weren't going to bring it in. It uses itertools. Python get elements from generator. Yeah, here it is, ittertools.islice. Print, oops. Let's pull in ittertools, print, ittertools.islice. We pass the generator and the number of elements we want. It's going to be length, and the generator I called genMSF pattern. Function is not iterable. So I've got an islice object. Do I just join it to an empty string? There we go. Okay, that's still broken as well. So I think it's my generator that's broken, not the cyclic code I stole. How is my generator broken? AA0 is fine. So then it adds 1 to this offset. AA1 is fine, but then it goes to AB2. And it goes to BB2 and stays stuck on BB2. Let's go and comment that for I in. I'm actually going to put that there. Alright, that fixed it. So it was my optimization. Why does that optimization break it? Why is that not the same as this? So I did not do this optimization last night. So it's fresh to me now. Why is that optimization breaking things? Any ideas? The input's range is an iterator and doesn't get reset. Range isn't an iterator. Range is a function that returns a list, not an iterator. Right? xRange is an iterator. Range 3 is a list. xRange 3 is an iterator. Of sorts, I think. Range is an iterator and doesn't get reset. I don't know what you mean by doesn't get reset. I mean, things shouldn't be needing to get reset. I mean, when you enumerate, what if we enumerate this? Returns an object. Yeah, like, I mean, I don't think there's any resetting going on. That should persist throughout the life of the generator. I'm not trying to change this. Offsets doesn't change in length. Like if we were to get rid of this and hard code for I in 2, 1, 0, because that's basically what this is. It's the list 2, 1, 0. It's fine. If I do offsets indexes reversed equals 2, 1, 0. Bring that back in. Things are fine. That there should be the same as that, yeah? Because at this stage, offsets is 0 times the length of sets. Sets is already set. It's defined. So this should be 3. So this should come out to be 0, 0, 0, which means length of offsets should come out to be 3. Range of 3 should be 0, 1, 2. Should be able to reverse it, and that should just be 2, 1, 0. That's bizarre. Oh, I think it's bizarre anyway. Okay, reverse is an iterator. Yeah, okay. Thank you. You're exactly right. Reversed is an iterator. Interesting. Gotcha. Yeah, and its state is not necessarily persisting properly. Can we just cast that to a list? There we go. Delete that, delete that. Cast this to a list. Delete that, delete that, delete that. Okay, so we're back to where we were. The only thing we changed is basically casting this iterator to a list. This is something that looked pretty ugly. You could almost just replace that with offsets blah 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 equals 2, 1, 0, but I don't like hard coding stuff like that. I like it to be based on this here, which is why I want to do this. If we run that, okay, that works. Let's do it for 100,000. We get that. SF pattern create.ruby. Cool. Has this fixed our performance problem as well? Is getting rid of that iterator that might be what was so that might be one of the things that was so expensive, having that iterator hang around. I didn't know it was an iterator. Thank you very much for calling that out. That's bang on. That saved me a lot of head scratching. Thank you. Let's go look at. Do I have Vim already? Yeah. Do I have buffers? Yep. Let's go edit. Edit benchmarks. So now we've got cast the pre-calculated blah to a list. And now let's have a look at what time we get. Man, it's still slow. 4 seconds. It's quicker. We've saved about a second there by basically chucking that iterator away and getting a list. I'm going to continue doing some performance tweaking offline. It's something I'm not too familiar with, so I don't want to stumble through it and waste everyone's time with it. But now that we've got the trick of casting that to a list, let's go back to Pwntools. Let's look for our generator. And we just cast this to a list. Pwntools, we pip install. Start Python, import pwn, pwn.cyclic metasploit 2024. There we go, that looks pretty good. Let's test that. Python -c, import pwn print, pwn.cyclic metasploit 10,000, get a hash. That's 10,000. Alright, those hashes match. So we've got a faithful implementation. Python, import pwn.cyclic metasploit 2024. Let's go and get 4 characters. Pwn.cyclic metasploit find of those 4 characters. We get an offset 779. Let's check that against Metasploit. Tools, exploit. Pattern offset. Query for that there. We should get 779. There it is, 779. Alright, so we've got a faithful pattern generator, pattern finder. I've still got some things left to do. I need to optimize performance. I need to cause the generator to terminate when it reaches the end of its list so that it doesn't loop forever when it's trying to find stuff that doesn't exist. Got a few other bits and pieces to fix up, but what we can do to finish this off is put in some usage. Def cyclic, some examples. Python. We've got to do from pwn import star. Then we do cyclic metasploit. They give the example of 20, so we'll do 20. There we go. Copy that. Paste it in. Get rid of these because they're not relevant for us. There we go. We've got some usage. Cyclic find. Examples. Cyclic metasploit find. Cyclic metasploit of 1,000 from 514 to 518 gives us 514. That's kind of making sense because all we're doing is we're doing a cyclic metasploit of 1,000 characters, carving out the 514th to the 518th character, which should give us an offset of 514. So we copy that usage there, paste that in. Let's just go and comment this out. So I need to implement this here so that I can have that sort of example pop out and have it documented here. Apart from that, that's all the help we need to do. Cyclic metasploit. Did I just go and put usage on the wrong things? I totally did. I went and put documentation for metasploit on the cyclic function. I'm not a smart person. Back all that out. Okay, so that's the change we want. Damn it. Alright. Cyclic, we had the example of cyclic metasploit 20. There we go. Delete these. Metasploit find. We wanted to do this one later. Once it's implemented, I'll go and put that example in. Otherwise, we've got this here. Doco is done. I've still got to do some tidying up, some to-dos, but we can install that. And then what's really nice, I only just found this out last night, if you do Python, import pwn, you can do help pwn.cyclic metasploit. There you go, you actually get interactive help from within the Python REPL, showing the doc string that you wrote. So you can go and check the usage of stuff right from here. Like I think you can probably do help print. Nope, didn't like that. Did not like that. Range. There you go, you can actually get function help from within Python, which I thought was really neat. So that's something I learned just last night. That's it for me tonight. I'm going to probably spend a little bit of time reading up on Python optimization because I'm really curious, but I'm not going to be too far from bed because I am exhausted. So thank you for sticking around tonight. Hope you got something out of it. It was a bit of a different night tonight. I was really hoping to actually finish this addition to Pwntools off. But unfortunately it was not meant to be because I am not clever. What have I missed in chat? When you call reverse, the return listener, yeah, that was very, very well caught. Cool, I'm going to call it a night. Thank you for sticking around. I do appreciate it was a bit different tonight. We will get micro corruption done next week. I hope to have this sent off before then, fingers crossed, although I do have RuxCon this weekend. If you're heading to RuxCon, hit me up, let me know, we'll grab a beer together. I will not be streaming this weekend because I will be in a state of great disarray, I'm sure. It'll be Sunday evening, it'll be the last night of Rux. Yeah, Jadeth, I'll catch you at Rux. See you later, Pritch. Thanks everyone for sticking around, thanks everyone for dropping by, and I will catch you all on the tubes. Take care.